Okay, we're going to be finding the derivative of f of x, and then we're going to evaluate it, the derivative at x equals 3. Now we're going to do this by using what's called the definition of the derivative. So this is kind of the long way around of finding the actual derivative of f. And this is our definition of finding the derivative, and the derivative will exist as long as the limit here exists. Okay, so this is the formula we're going to use here, and remember that this is really the slope of the secant line, but then we're introducing the limit here as delta x approaches 0, and that's going to end up becoming our tangent line. So slope of the line, that's where this comes from. Okay, so we're going to take this x plus delta x, and we're going to put it right in here for x. So pretend this is just all one single object, and we're going to move this x out of the way and substitute in the x plus delta x right underneath the square here. As you can see, plus, and then this x right here, we're going to replace it with all of this stuff. So we have x plus delta x minus, and then our function f of x. We just rewrite our function here, and it's all over delta x. And now we're going to take the limit of delta x approaches 0, and if I were to actually do that and do the direct substitution, plugging 0 in for delta x, we would end up getting something that doesn't look good. Okay, so you'd end up getting 0 in the denominator. And like, for example, a 0 would go in here, a 0 would go in here. So you'd end up having 1 over x plus x minus, well, this would become 1 over x squared actually, minus 1 over x squared. Those would cancel out. This x and x would cancel out. And so we'd end up getting 0 in the numerator and 0 in the denominator. So we need to try to simplify this down as much as we can. And so what I'm going to do here is I'm going to square this. This is x plus delta x. And so you're multiplying x plus delta x times x plus delta x, right? And so you end up getting x times x is x squared, x times delta x times x, which ends up being 2x delta x, and then delta x times delta x is delta x squared, plus, and then just dropping the parentheses, minus, I distribute this negative across, as you can see here. Alright, and let's see here, the x's cancel out, so that's all I've done with an extra step there. Now we got to get this into one single fraction here. So that means I need to get a common denominator. So I write x squared over x squared. This problem here is kind of long, so I got to scoot this along. Writing x squared over x squared, I write x squared plus 2x delta x plus delta x squared over, as you can see here. And then down here, I just have to rewrite this part here over it. Now we've got a common denominator. So I pretty much just add the top, so we end up with, so this would be the x squared times 1, x squared, and then this next piece here, as you can see here, and then the last piece that was on the end back there. And then it's all over, and I just went ahead and dropped, no, I didn't do anything yet. Okay, so there I am. Now we go ahead and simplify that top. I distributed the delta x across and the x squared, and we end up with this stuff here, and then simplified as much as I can. Okay, so we get down to this final piece here. We can't do anything more, and then we go ahead and do the direct substitution, plugging 0 directly in for the delta x. As you can see here, and finally f prime of x is equal to, so this is our derivative, and then we wanted to evaluate it at 3, and we plug 3 in and we get 25 over 27. Here's the graph of our function, and the green line right here is our tangent line, and it has, remember, a slope of 25 over 27.